Okay, so here we are. We are going to talk about slope. Raise your hand if you've seen the word slope before in a math class. It looks like everybody, at least everybody, is paying attention to the question. Super. So slope. In this lesson, we define the slope of a line, and we see several ways to calculate and use slope. All right, here we go. Number one. Portion of road A climbs steadily for 120 feet over a horizontal distance of 4,250 feet. A portion of road B climbs steadily over for 95 feet over a horizontal distance of 2,875 feet. Which road is steeper? That is the question we are going to answer. Which of those two roads is steeper? So we're going to draw two diagrams. One of them is drawn out for you. Let's make sure we're clear on exactly what's going on. You've got a horizontal, a vertical, and a diagonal line in that triangle. Which one of those three lines is the road? It's the diagonal, right? Because I'm telling you that we've got a climb of 120 feet, that's the vertical. The horizontal distance, we're going to call that the run in a few minutes, is this 4,250 feet. The road is that diagonal, okay? Driving on that inclined road. Also note that this diagram is wildly not to scale. Agree? Because 4,250 is something like 40 times the, is that right? 40 times the 120 over there, and it's not to scale at all, which is totally fine. All I'm saying is don't read much into the scale of the diagram. So here's my diagram for road B. You got two other numbers in this problem. Go ahead and fill them in. 95 feet, 2,875 feet. Let's see, so where does the 95 go? The vertical, so it says it was climbing 95. 2875, that's the horizontal, so we'll put that down here. And just like before, the road is this diagonal line. All right, and we're trying to figure out which one of these is steeper. And to be honest, I've chosen the numbers here, so it's really not obvious. Which one climbs more? Just raw numbers. Which one climbs more? A, because it climbs 120 feet compared to the 95 feet, right? So A is like higher at the end of the day, right? If you're thinking of two mountaintops, A is the higher mountaintop. But road B doesn't take as long horizontally to get to that shorter height, right? And so we got to compare these two numbers to each other, the vertical and the horizontal, in order to decide which one is steeper. So for a reason that is not obvious to me, everybody mathematically decides to do the ratio rise over run, vertical over horizontal. So for A, you can see that I've got my 120, that's the vertical, and 4250 is the horizontal, right? You could totally do the same thing, just flip it over, as long as you're consistent. But I am telling you mathematically, you guys know the word slope already from a previous math class. You guys know it's the vertical on top and the horizontal on the bottom. So that's what we're doing here. So 120 over 4250, my calculator says is 0.028. It doesn't really have units, so it doesn't make, there isn't much to say about that other than to say it's something like, what can we say, 0.028 feet vertically for every foot horizontally. For every foot you go horizontally, it's not very much up, 0.028 feet, but anyway, that's the units. Okay, fill in the blanks for the steepness of B. Remember, it is always vertical to horizontal. So put the vertical number on top, put the horizontal number on the bottom, type the thing into your calculator. All right, who's got a number for me? Louder, Aneri? 023? 33. Thank you. Okay. And let's get those same units. I don't think about these units that often, but I'll just put it here. That's 0.033 feet vertically for every 1 foot horizontally. And by having those units there, it actually allows us to make the comparison from the one mountain to the other. Because both of these numbers now reference traveling horizontally a single foot. Maybe I should make this explicit. 1 foot on the bottom, 1 foot on the bottom. Now we're comparing apples to apples. For a horizontal foot traveled, I can now say what we're traveling vertically. On the first case, we're traveling 0.028 feet up. On the other one, we're traveling 0.033 feet up. Which one is steeper? Is it the smaller number or the bigger number? It's the bigger one, because for both of them, you're walking a foot horizontally, and then you're walking just this little tiny number up, but whichever number is bigger is going to be the one that's steeper, right? And the 0.033 is a slightly bigger number. So B is steeper, and here is a full credit sentence. Since the steepness of B, which is this 0.033, is greater than the steepness of A, which is the 0.028, road B is steeper. This is a very common quiz question for me. It's to write a complete sentence, and your sentence needs to get the two numbers in there, and also this word greater. Gotta make sure you get the right answer. B is the steeper one. Okay, so I'm using the word steepness, but what word do you guys know that as from a previous math class? Slope. So really, it's the slope of the one being bigger than the slope of the other. So here's our definition for number 2. To measure the steepness or slope of a line, this non-vertical thing we won't worry about today, we use the ratio that measures the vertical change in the y-coordinate, that's called the rise, to the horizontal change, which is the x-coordinate, or the run. It's the same calculation we just did. Shorthand notation for slope uses the symbol delta, looks like a little triangle, which oftentimes in math or science represents a change in. And for some reason, we use the letter M to stand for slope. That's something you've seen before. So lots and lots of ways to think about slope, all written out here. Slope, which we can use the letter M for, is the change in the y over change in the x, right? That's the vertical over the horizontal. If you actually have coordinates given to you, oftentimes we use these little subscripts here, y2 minus y1 over x2 minus x1. I never think of that formula. I just think of change. And I know the change means subtracting, right? You have 2 and you get to 5. What's the change? It's 3. Here's our favorite Greek letter, delta y over delta x. Again, delta just stands for change. So change in y over change in x. And then finally, in kind of plain English, it's the rise over the run. All saying the same thing. Okay, so let's take a look at number 3, which references this problem from a previous class. We had this equation, y equals negative 200x plus 800. I think we had that last class. Is that true? And it had to do with the altitude y of a hot air balloon in feet, x minutes after we started releasing air from the balloon. And so I gave you guys that equation in a previous class, and I had you find the two intercepts, y-intercept, x-intercept. You connected the dots, and you described what was going on. So now what we're going to do is get another characteristic of that line. You've previously found the x-intercept and the y-intercept. Now we find the slope. Now, some of you might be able to tell what the slope is just by looking at that equation. We'll get there soon enough, but for right now, all we have is our definition. And the way to find slope is to pick 2 points on the line. So for example, 0, 800 is 1 point, and 3, 200, can you tell? Does that look like it's on the line? I think that's right there, yeah? 3, 200. And so if we're trying to find the slope here, so this is written out, and then we'll do one which isn't written out. Slope, which again is the letter M, change in y over change in x. So what we're supposed to do is compare the y values. We'll highlight in blue. There's a y value, there's a y value. What do I do with those numbers to find the change in y value? We subtract them. How much is the change? 600. We buy it? 800 minus 200, it's written out right there, 600. Another way to think of it, if we wanted to tie this to our road example, is if I draw in that vertical and this horizontal, what is the length of that vertical line? Isn't it 600? For the same reason, it's just the 800 minus the 200. Okay, and then that's the rise. And downstairs, we're supposed to do the change in the x. So I'll highlight these guys in green. What is the change in x? It's 3. So downstairs is 3. Should it be 3? Should it be minus 3? Yeah, which one is it? So we got to make sure that we're subtracting in a consistent order. So if we decide we're going to do 800 minus 200, which is exactly what I did on top, that's a fine choice. then we are forced to subtract in the same order downstairs. You can't just subtract in the easier order. It's easier to do 3 minus 0, but you got to subtract in the consistent order. If we wanted to do 3 minus 0. Yeah, exactly. So as long as these orange arrows are going in the same direction, you're good to go. If you choose 800 minus 200 on top, you must choose 0 minus 3 on the bottom. It's one of the few ways that we can mess up a slope calculation, is to not subtract consistently in the same order, top and bottom. Okay, so that one's a 600 upstairs and a -3 downstairs, and altogether is a -200. That right there is called the slope of the line. It is a measure of steepness. What we're going to do is pick 2 different points. Not these 2. Let's pick 2 other points. Somebody shout out another nice point that's on that diagonal line. 1,600. Do we buy that? 1,600 and 2,400. All right, how are folks feeling about Lenin's points? We buy that they're looking like they're on the line. So I want you guys to do the slope calculation right now with your neighbors. Upstairs, you are subtracting the y's. Downstairs, you are subtracting the x's. Make sure you subtract in the same order and check your answers with your neighbors. So hopefully we got -200. I've actually written, there's 2 different ways to do this calculation for these 2 points. If you do 600 minus 400, look at my orange points over here, and just be consistent with the order. If I do 600 minus 400 upstairs, what do I do downstairs? 1 minus 2, which is what I wrote here. 200 on top, -1 on the bottom. I know that's -200. But just as well, you could subtract in the other order. You could decide, I'm doing 400 minus 600. Perfectly fine. I've written that in black. But if you do 400 minus 600 upstairs, what must you do downstairs? 2 minus 1. 2 minus 1. Upstairs now is -200. That's different. It used to be +200. Downstairs is now a +1. How much is -200 over 1? Is -200. So that's really comforting, because it would have been a shame if we got different answers depending on which way we subtracted. And then the other observation here, how does this number compare to the slope we found with our first points? They're the same. And this is the idea. It doesn't matter what points you pick on the line. If you do your slope calculation, you will always get to the same result at the end. Okay? All right, on the next page, just a couple of observations here. We'll go to F. What does the slope mean in this situation? So again, you guys are going to be writing interpretation sentences. I think writing the units is really helpful. When we did the first calculation, we did 800 feet minus, how many, 200 feet? And they were both feet. So that's not just 600, but it's 600 feet, yeah? And then downstairs was 0 minutes minus 3 minutes. And altogether it is -3 minutes. And then we reduced that number and we got -200. But the idea of having feet on top and minutes on the bottom goes a long way to getting the sentence written down. Instead of this division line, what word can we use? Starts with a P. Which one? Proportion is a reasonable fraction word. I want a different word. That's -200 feet, something minute. Per. That's the P word. It's -200 feet per minute. And the sentence is just about written. -200 feet per minute. So I've got 3 versions of my sentence: good, better, and the best. They're all full credit, but if we can shift you down towards the better sentences, that would be good. So here's a good full credit answer. The balloon's altitude was changing at -200 feet per minute. Per is important, okay? A little bit better. To say it was changing at -200, that negative really means it was doing what? Decreasing, yeah? So maybe a little bit better. The balloon's altitude was decreasing at 200 feet per minute. Let me put something in here that makes this not full credit. Decreasing at -200 feet per minute. That's not right. If you say decreasing, you are taking care of that negative sign. Good? And then the best answer, maybe get rid of that word increasing or decreasing entirely and just replace it with falling. The closer we can get to plain English, the better our sentences are. So the balloon was falling at 200 feet per minute. Okay, there's really only 2 ways to get the slope wrong. One of them we talked about is whether you subtract in a consistent order on top as on the bottom. Just have to make sure you're consistent. The other one, Matt, can I pick on you? I think you did this. What did you do in your slope calc? Matt did it upside down. Which letter goes on top, X or Y? The Y goes on top. It's a change in Y over a change in X, but it's really easy to just do it the other way, and if you do it the other way, you get the wrong answer. It's only two ways to get the slope wrong. Last semester, one of my students came up with, he asked me, or one of the students asked me, why do we put Y on top and X on the bottom? And one of my students came up with, here we go, I don't know why Y goes on top. So if that is memorable to you, go with it. But Y goes on top, why? I don't know why, but Y goes on top. Okay. All right, activity starts on the next page. You're not going to get through all of it now, but just get as far as you can. We have another 13 minutes or so. Raise a flag if I can help.